Hi, Golden Achievers! My name is Sir Arnold M. Reyes, and for today, I am very excited to teach you Mathematics 7 representing sets using Venn diagram. Of course, enable for you to better understand how to represent sets using Venn diagram, you should be able to understand first what a Venn diagram is. Let's start. Venn diagram. When we say Venn diagram, it is a visual representation of the relationship between and among sets that consists of overlapping or non-overlapping circles inside a rectangle, where circles represent the different sets and the rectangle represents the universal set. Each set is described by a shaded region of the diagram. So I have here an example of a Venn diagram. So this is a rectangle that represents the universal set. So meaning this rectangle contains all the related elements. So next one, we have the two circles, where these two circles represent our given sets. So we have the circle A for set A and the circle B for set B. Let's have an example where we have the actual sets. So for our universal set, we have x such that x is a letter from the word mathematics. And for our set A, we have STEAM. For set B, we have MICE. Okay, so the first thing that we need to do here is to list down all our elements of the universal set. So we have M, A, T, H, E, M, A, T, I, C, E. And then we have to put it on our Venn diagram. So as you can see here, we have the circle A, where the circle A contains S, T, E, A, M, where these elements are the elements of set A. And for set B, it contains all the elements of set B, which are M, I, C, and E. And we have here the element H, which is not contained in either set A or set B, so it will just be contained on the universal set outside the circles. Now observe the elements. Did you see some elements moved? Of course, we have the elements M and E, which moved towards the middle, where they represent the common elements. Since the elements M and E are found on both sets A and B, then therefore they will be the intersection of our two sets. And since they are the intersection of our two sets, in Venn diagram, we write them on the intersection of our two circles. Now, sir, how are we going to represent different sets using the Venn diagram? That is actually a good question, where we use the Venn diagram to represent our set through shading. What are we going to shade? We are shading the correct region that represents a specific set. Let us have an example. We have set A. What do you think is the portion on our Venn diagram which represents the set A? That is correct. It is the whole circle of A. Then therefore, we have to shade the whole circle of A. Then it shows that the shaded region contains the elements S, T, E, A, and M. Another example. Set B. How are we going to represent our set B? That is correct, by shading the whole circle of B, where it shows that the shaded region contains the elements of B, which are M, I, C, and E. But what if our sets that we need to represent using the Venn diagram contains set operations? Example, set A union B. And we know the operation union is about combining the elements of our given sets. Then therefore, if we are going to combine sets A and B, then we have to shade all the circles of A and B. And this is the representation, where the shaded region contains the elements of A union B, M, A, T, E, I, C, and S. Another example that contains set operation. We have set A intersect B. The word intersect or the symbol intersect represents the commonality or the common elements of our given two sets. Then, since we are representing the commonality using the intersection, using the Venn diagram, it must be the middle portion of our given two sets, which are the elements M and E. Then therefore, we have to shade the only portion that contains the M and E. Another example. Set A minus B. This time, the set operation is difference. So meaning we have to eliminate all the elements contained in set B from A. Then therefore, we are just removing any portion or any relationship of set A to B. Then we need to remove their intersection. That is how we get set A minus B. Then therefore, set A minus B will only contain S, A, and T. Another example. Set B minus A. So as you can see, it's the other way around. This time, we need to remove all the related elements of set A from B. And this should be the representation, where we only have to shade the portion of B without A, and that contains C and I. How about set A prime, where this represents the complement of set A, meaning we have to remove all the elements of set A from the universal set. And this is the representation using the Venn diagram, meaning we are removing the circle A from the universal set. And the remaining elements would be our answers, which are C, I, and H. How about set B prime? So this time, we have to remove the circle B from the universal set. And this is how we represent it using the Venn diagram. So the remaining elements would be S, A, T, and H.